Have you ever stopped to wonder how we actually make sense of the vast, complex, and honestly, seemingly chaotic expanse of the natural world? I mean, when you look up at the night sky or even just look at the screen sitting right in front of you, the sheer scale and mechanics of the universe can feel entirely overwhelming. But what if I told you that we can decode literally all of that complexity using just a few simple fundamental building blocks?
Whether it's the mechanical swing of a shiny metal pendulum, the sudden crackle of electricity, or right down to the fundamental particles zipping around inside an atom, physics is really just the curiosity-driven study of the inanimate natural world. It spans everything from empty space and light to the ultimate fate of the universe itself. And our main goal in this explainer is to take these massive, intimidating concepts and make them good and easy to understand for you.
So, welcome to this explainer, the science of measurement, understanding physics. Today, we are going to completely strip away that intimidation factor that usually tags along with this subject. We're bypassing the dense mathematical hurdles, and instead, we're going to focus on uncovering the profound simplicity of nature. You know, physics is widely appreciated for the sheer beauty of its concepts, but its real value, that lies in its immense predictive power and the life-improving applications it brings us. Let's dive in and demystify it together.
Here is our roadmap for today. First, what is physics? Second, the science of measurement. Third, the 7 basic quantities. Fourth, translating the universe. And finally, the fundamental forces of nature. Starting right off with Section 1, what is physics? The study of the inanimate natural world. Moving right along to Section 2, the science of measurement. Comparing unknowns to knowns.
Because physics deals with matter in relation to energy, and accurately describing natural phenomena, you really can't have physics without measuring things. It's absolutely crucial. And that brings us to a foundational definition. Measurement is simply the act of comparing an unknown physical quantity with a known fixed standard called a unit. Picture a bustling vegetable market. When you buy produce, the vendor takes an unknown weight of vegetables and compares it against standard, known masses on their scale to find the exact value, right? That standard piece of metal on the scale is the unit. It's a charmingly simple concept, but without standardized units, it would be almost impossible for scientists to express and compare measured values in any kind of meaningful way.
Which leads us to Section 3, the 7 basic quantities, the profound simplicity of nature. Now, this is where it gets really fascinating. Out of all the vast ranges and wild complexities out there in the universe, a profound simplicity appears when we look at basic quantities. It's incredibly elegant. Absolutely all physical quantities in the universe can be expressed as combinations of just 7 basic foundations. We're talking length in meters, mass in kilograms, time in seconds, and temperature in Kelvin. Every single thing we measure in the inanimate natural world traces back to these exact 7 rows. And from those 7 basic blocks, we get what are called derived physical quantities. We define these simply by stating exactly how they're calculated from the basic measurements. So, for example, if we want to measure average speed, we don't need to invent a brand new fundamental unit. We just define distance by measuring it out with a meter stick. We define time with a stopwatch, and then we just state that average speed is calculated as the total distance traveled divided by the time of travel. It's entirely built on the basics. It really is that easy to understand. Next up is Section 4, translating the universe, converting units globally.
Since science is a massive global team effort, we have to be absolutely sure we're all speaking the exact same mathematical language. We pull off this translation by multiplying by conversion factors. The whole goal is super simple. You perform an operation in such a way that you cancel out the units you want to get rid of, and you introduce the units you actually need. Have inches but need meters? Just multiply by 0.0254. Have pounds and need kilograms? Multiply by 0.4536. It's a universally agreed upon translation guide.
Let's apply this with a real-world example to see how it works. A common city speed limit in Ethiopia is 30 kilometers per hour. Now, if an engineer from a country that uses the imperial system is trying to analyze their traffic data, they can use our conversion operations to seamlessly translate that 30 kilometers per hour right into miles per hour, ensuring total accuracy across borders.
Or consider this one. The average body temperature of a house cat is a cozy 101.5 degrees Fahrenheit. But if a veterinarian wants to publish a global study on feline health, leaving it in Fahrenheit might cause a lot of confusion in metric-only regions. By converting that 101.5 degrees into Kelvin or Celsius, the true value remains perfectly intact and understandable when shared globally.
And finally, Section 5, Fundamental Forces of Nature. How measured quantities interact.
When these measured physical quantities, the masses, the lengths, the electric currents, when they actually interact with each other in the real world, things get incredibly dynamic. But here is the secret. All forces of nature, no matter how wild or complex they seem, can be traced back to fundamental interactions. Scientists characterize these based on 4 very distinct criteria. First, what types of particles are involved? Second, what is the relative strength of the force? Third, what's the range over which it's actually effective? And fourth, what is the nature of the particles that mediate or carry that force? Every single interaction out there passes through this exact analytical lens.
Zooming way out, we can basically categorize all these forces into 2 main buckets: contact forces and non-contact forces. This brilliantly highlights the high-level division of our physical world. You have forces that require actual physical touch to interact versus forces that govern how particles influence each other from a distance, like gravity or magnetism. So as we wrap up this explainer, I want you to consider this. How do the infinite, seemingly chaotic interactions of the entire universe trace back to just 7 basic quantities? From the simple swing of a pendulum to the extreme outer limits of a galaxy, everything we measure, everything we calculate, and literally every force we feel